Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Today, we are going to talk about hydrolysis of acyl chloride. Acyl chloride is having a functional groups like this. It is C double bond O, Cl. So this is acyl chloride. Hydrolysis of acyl chloride require water as the reagent. Condition is just room temperature. For the observation, it is upon heating, the fumes of HCl are liberated. Now, let's look at an general equations of the hydrolysis of acyl chloride. This RCOCl, when it reacts with water, the Cl is going to replace by the OH. So you will get RCOOH plus HCl. This reaction is actually very vigorous, occurring radially in cold, where heat is evolved, which means this is actually an exothermic reaction. So if you heat the reactions, the fumes of HCl is going to be liberated. Okay, and also it says that HCl is produced and it gives immediate white precipitate with of AgCl with aqueous Ag anode. Which means, now let's say in the reactions flask where we have acyl chloride, RCOCl plus HCl plus H2O. So imagine when the reaction is completed, HCl is going to produce as well. So we have our carboxylic acid and also HCl. But how do we confirm that the reactions? How do we confirm the rate of reaction? It is by adding Ag and O3 inside, which means the moment the HCl is formed, the HCl is going to give off the Cl minus, whereas the Ag is going to give off Ag plus. So the Ag plus in aqueous state and the Cl minus in aqueous state will form, so when these two react, they will form AgCl solid, which is a white precipitate. Which means I can say that the rate of the reaction is equals to the rate of the AgCl form. Alright, so now we're going to look at a few examples of acyl chloride, hydrolysis of acyl chloride. Let's say if you have CH3, CH2, Cl, COCl plus water, you will get CH3, CH2, COOH plus HCl. You can see the only changes is where Cl becomes OH. Alright, now let's say we're trying to make the things more complicated by drawing a skeletal formula, for example. Alright, now let's say we have this. Upon reacts with H2O, it will form COOH over here. So all these are the example of hydrolysis, and the reaction is very vigorous because acyl chloride itself is very reactive. Next, we're going to discuss the mechanism of the hydrolysis of acyl chloride. Now I give you the general equation first. Let's say we have a CH3 C double bond OCl reacts with water. We know that eventually we're going to get COOH plus HCl. So in order to show them the mechanism of this hydrolysis, it requires a few steps, okay? And usually 3 marks will be given in mechanism. So how do you gain all the 3 marks? First, you must be able to show all the dipole or the charge on the ions or the compound, and you must have the curly arrow. Curly arrow shows the movements of electrons, and lastly you must have your intermediate. Alright, now we're going to start with the mechanism. CH3 C double bond O Cl reacts with water. So let's draw the water over here. Alright, now we're going to first label the dipole of the acyl chloride, where this carbon is a delta positive and this oxygen is a delta negative. Alright, and the first step is the attack of the more negative side to the more positive side, which is from the lone pair of the oxygens towards the carbon. For this oxygen, it is actually a delta negative side. Alright, now second step. Now I want you to notice that whenever a bond is formed to the carbon, this carbon is having how many bonds right now? Let's see. Yeah? It becomes CH3, C, Cl, a new bond is formed. This O is having a lone pair and a H is here and the H is here. Now what I want you to take note is that the 2 electrons over here has already moved to form a bond with the carbon. But I want you to imagine if, let's say, this carbon is still having a double bond here, then it will be wrong because the maximum bond for a carbon is just 4. So therefore, these 2 electrons, okay, these 2 electrons that stays in the bond will move upwards to the oxygen. So right now, you're going to have your oxygen single bonded to this carbon, and originally these oxygens already have 2 lone pair. Right now, it has a new pair of lone pair like this. So now we are going to discuss the charge on this oxygen. So this oxygen is going to acquire a negative charge. Then some students might ask, why not 2 negative? Why is it just 1 negative? That's because for this oxygen, now if you look at this bond clearly, okay, now this bond, there's 2 electrons here. But you need to understand that this 2 electrons belongs to oxygen, and this 2 electrons belongs to the carbon. So when this 2 electron is moving up to the oxygen, this oxygen actually takes only extra 1 cross from the carbon. So therefore, it is just 1 minus from here. Alright, what about the charge on this oxygen? Now this oxygen is having 1, 2, 3, 4, 5 electrons. So it is lack of 1 electron. So therefore, the charge is going to be positive. Alright. So now always remember in the exam, all the dot and cross over here is not needed to show. Alright. I'm just showing for your understanding. Alright. Now the next step is that we are going to take away this H. So how do we take away this H? Now imagine right now you have 2 electrons on this bond, all right? So this 2 electron is going to move back to this oxygen, which means this H will just leave without carrying any electrons. So it becomes H plus, all right? So therefore, your structure is going to be like this. CH3CCl, where the O is having 3 lone pair and a minus charge over here. And for this O, it is having a H here and a lone pair like this. So why is this lone pair? Because 2 of this electron has already moved to this oxygen. Alright, so the next final steps is where the 2 electrons over here move back to form a double bond O. So imagine right now, this carbon has 1, 2, 3, 4, 5 bonds. Like I say, carbons should have only 4 bonds, right? So there's 1 bond extra. So therefore, the extra bond, which is this bond, will have to leave. So 2 of these electrons will have to move to this carbon. Alright? So therefore, you're going to have your CH3, C, double bond O, and your OH is here. Okay? So the Cl minus over here will combine with the H plus that is being eliminated to form a HCl. So this is the complete mechanism of the hydrolysis of acyl chloride.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.